Alright, so I'm going to show the answers to this and then talk through them. For number 1, they gave you an equation and they gave you a list of numbers and they called it the domain and asked you to find the range. So that means we need to take all of our x values from this domain, put it back into this equation and find each of our y values. And then because they gave us the domain in a set of numbers or that list of numbers in curly brackets, we have to do the same thing. Put our y values or our range back in this curly bracket, back in these curly brackets, least to greatest. So that would be -2, 0, 4, and 10. Questions on number 1? For number 2, you had to decide if these were functions or not. You could use the vertical line test. For the vertical line test, if it touches at more than one place, it is not a function. If it doesn't touch at more than one place when you draw your vertical line, then it is a function. So this would not be, and these two would be. And then number 3, you needed to find the slope of the given point. So use your y2 minus y1 over x2 minus x1. So -2 minus 3 all over -5 minus 2 to get -5 over -7 or positive 5/7. Questions on number 3? On the back. So this number 5 is not you guys' number 5, but I have that number 5 somewhere else. For number 4, you guys needed to find the x and y intercepts of this equation. So put 0 in for x or for y, and then solve for the missing variable. If you skip down to this step, where it's just the variable term and what it equals, that was fine. Divide both sides. So your y-intercept was 0, 2. Your x-intercept was -4, 0. Make sure to put your intercepts as ordered pairs. And then number 5 that you guys have was this one where you had to solve this equation for y. Add 3x to both sides. Rearrange this so that it starts to look like slope-intercept form. -3y equals 3x plus 9, and then divide everything by -3. So you get a positive y, a negative x, and -3. Questions on any of those? Before we start our list, I just wanted to mention this in case we have a code orange on Tuesday.
Colors. Like one's not purple, the other one's blue, and then red.
I know red is for basically everybody. Green is for students and teachers. Admin still has to come in. Orange is no one really comes in. And this year, what Dr. Huey said, like that we go on Zoom for an hour. You guys can come in if you have questions or need us. Next year, Code Orange is going to be basically virtual instruction. But if we were to have Code Orange, I'll post that announcement. But you guys can click on this link right here, virtual office hours. It'll take you directly to my Zoom. You shouldn't need to put in a password or anything like that. You may need to sign into your own Zoom though. And that should take you directly to that. The math time is from 1 to 2. So if you need me for any reason on Tuesday, if you have a Code Orange from 1 to 2, you could join my office hours and I'll help you. Don't feel like that you have to do that, because again, it is optional. But if you need me, I will be there. Or if you just want to stop by and say hi, because I'll just be there. If you haven't already, take out these notes that I gave you on Tuesday. If you need another one, I should have some in the teal crate and the Unit 5 folder. So as we start these notes, some of this will look familiar, like we've done it before. To some extent we have, we just didn't talk about it in this sense. So it will look familiar. We will have done some of this stuff before. The wording and what we call it and things like that will just be a little different. So this unit is on variation, how things vary with each other. So first let's talk a little bit about direct variation. A direct variation is a specific relationship in which there is a constant ratio. You can write that as y over x between all ordered pairs. Direct variation equations are written in the form y equals kx. So when you look at that equation, it should look somewhat familiar because it kind of looks like our slope-intercept form, but it's not an m, it's a k, and there's no b, but it kind of looks like that. So in that sense, it's related to something we've done before. So when we talk about direct variation, there'll be some instances where we have to find the k. In here, they'll call it constant of variation. On Khan Academy, it's called constant of proportionality. Those are the same thing. So to find our constant k, if we were to solve this equation, so I'm going to rewrite it so I can actually solve it, I would get rid of x by dividing it on both sides. That's where that ratio comes from, that y over x. That is our k. That's how we find k, or our constant of proportionality. You can kind of think about that like a slope, because slope is y over x. So in this, you'll be given different things. Ordered pairs, tables, we'll talk about graphs here in a bit. But to find our constant k, we're going to use y over x and figure out what that number is. So for this, it would be 4 over 1, or just 4. So we could say my constant k is 4, but we need to make sure that it applies for all of the numbers, because it could work for the first one, but not for maybe the second or third, and then that wouldn't be your constant, because it's not the same for all of them. So really quickly, we'll go through and make sure that all of these are 4. 8 over 2, that's 4. 12 over 3, that's 4. 16 over 4, that is 4. Since they are all equal to 4, we can say for sure our constant k equals 4.
Is the x value on top?
It's a trick question.
Never. Y on top. Always. Y on top. No. When you're looking at the point, make sure you put the y value on top.
Once you know that your k is the same for all of your points, then you can write this using your direct variation equation. Your y equals kx, so that will be y equals 4x. Before we move on to another one, does anyone have any questions on how we found k or the equation? We're going to skip into number 3. Number 3 is not on a table, but we're still doing the same thing. We're doing y over x. So in this case, that would be negative 8 over negative 12. And then we could simplify that. Divide both by negative 4, or 2/3. So it means every time we divide, it would need to be 2/3 in order for this to be a direct variation. Negative 4 divided by negative 6. That would simplify to be 2/3. I'm going to skip this one and come back to that. 0 divided by 0 would obviously not be 2/3, but there's a reason why this still works. And then 2 divided by 3 would be 2/3. So everything besides that 0, 0, the constant is the same. The constant k is the same. And I'm going to go back and look at the equation. If this were like your slope-intercept form, what would your y-intercept be? B. And what is your b in this case? In the original equation? 0. So for direct variation equations, it has to go through 0. Your y-intercept has to be 0. So in this example, the constant k doesn't work at this point unless you're counting down to that point or up to that point. But it does go through that point. It has the y-intercept of 0. So because of that, this still works. It's still a direct variation. So I could write this as the direct variation equation, y equals 2/3 x.
So what you're saying is if there's a 0, it still works.
Yes.
Okay.
Now, if this were something else, let me put in random numbers. If, let's say, these were switched and this was 2 and this was 3, so now the fraction is 3/2, and there's no zeros, well, now your k doesn't work for all of them, so this would no longer be a direct variation, because your slope or your k is not the same. But that's not the case, I just made that up. Any questions on that before I let you try these two? Take a minute or two and try 2 and 4, and then we'll come back and talk about those. For number 2, what did we find our k value to be? Negative 1/2. And then what was our equation? Were you raising your hand?
It would be like A equals y over x. Oh, you just talking about y equals negative 1.
And then what was our k value for 4? Negative 3. So our equation for that one is y equals negative 3x. Right, when we come back, we'll continue this. Alright, let's continue these notes. The bowl first. Does anyone have questions on those two? I know we finished them really quickly before lunch. The next part, we are now given equations. We have to determine are these direct variations or not, and if they are, identify what k is. So if they are written in the form y equals kx, which would mean they're a line, so they're linear. So if they're linear and they have a y-intercept of 0, then it's a direct variation. If it's not a line, so let's say I had like 4, 2, square root, cube root, something else that would make this not a line or not in slope-intercept form, then you can say it's not direct variation. Or if it's a line but the y-intercept is not 0, we can say it's not a direct variation. So for number 1, is this a direct variation? Yes. So since it is, what is our value of k? 3. Is number 6 a direct variation? Plus yes. Yes. And our value of k, -4. What about 7? No. This one does not have an S. This one would be a line, but it doesn't go to the origin. And it's a horizontal line, so this would not be 1, so we don't have to find our value of k. For 8, we would need to solve it first. Divide both sides by 2. Now it looks very similar to 6, so we can say yes, this one is. And our k value would be 5/2. Would 9 be a direct variation? No. The y-intercept is not 0, so we would not need to find our k value. I want you to go through and do numbers 10, 11, 12, and 13, and then we'll come back and we'll talk about these. For number 10, was that a direct variation? No. Yes, that one should be. It is in the form y equals kx. Your k here would be -1. What about 11? Is that a direct variation? What if I rewrite it like this? Yes. Remember that you can rewrite this one, so this one would be 1, and your k value would be 1/2. Would 12 be a direct variation? No. And 13? Yes. Where k equals -5. Do we have questions on any of those 4? On the next page are graphs. So it's basically doing the same thing. If it's a line and it goes to the origin, it's a direct variation, and then we can find our constant k. If it's not a line or doesn't go to the origin, it would not be a direct variation. Would 14 be a direct variation? Is it a line? Yes. Does it go to the origin? Or does it have a y-intercept of 0? Yes. So it would be a direct variation. To find our constant k, remember that's like slope, so you would just count your slope. What would that be? 3/2.
Rise on the line.
Would 15 be a direct variation? No. It doesn't go to the origin, so it can't be 1. Would 16? Yes. And then we need to find our k value. What would that be? 1/4, it's negative. And then 17. Yes. And what is our k value? 1.
Is the k value the same slope, the same value as the slope? $1 million.
Yes.
Yes?
Yes.
Is it? For $1 million, Marta?
Yeah,
You got $1 million.
I wish. Alright. The next part of this is now we're going to be finding missing values. for either X or Y. And there are two ways to go about doing this. So I'm going to show you both, and then you can either choose one that you feel more comfortable with and stick with that. If you want to alternate, you can do that. The first way we're going to do this first is going to be using proportions. To find K, we do what? Or how would we find K in any other scenario? Say that again. Besides that,
Gives you detailed description.
what is the ratio for K? Y over X. So if we know that much, then we can take this and set it up as a proportion. -4 over 2 equals Y over -6. Because the K would need to be the same for both sets of pairs, ordered pairs, we can do this. So because we've now set it up as a proportion, we would cross multiply. So 24 equals 2Y. And divide both sides by 2. Yes. We could double check to make sure this works. -4 divided by 2 gives us -2. So that would be our value of K. If I put 12 back in, 12 divided by -6 is -2, so the K values are the same, they equal. Before we do the next one, does anyone have any questions on how we set that up, solved it, or got the answer? We're going to jump to 21. This one we're going to do a little bit differently. So for this one, because we know we can find K using Y over X, we're going to kind of use that method, but a bit differently. It'll look somewhat similar to this, but not at the same time. We're going to take the numbers we know, so 6 and 24, and do 24 over 6, which we know is 4, to find just the value of K. Once we have that value of K, we can write our direct variation equation. Y equals 4X. And then look at what we're missing. We're missing X, but we're given Y. So we can put -16 in for Y. And now solve for X by dividing both sides by 4. So if I were to go back and check this, now I have two different ways I could check this part. And really, you could have checked this same thing here. You would have just had to do a little bit more work. If I put -4 back into this equation, -4 times 4 does equal -16. And -16 over -4 does equal 4. So it works in the equation, and it works to find K. So I can say this is my answer. This works. So when you do these problems, you can either set it up as the proportion and solve it that way, or find your K, do your equation, and set it up like that, and find it that way. Either or, you could do both. Don't do both on the same problem, but you could do both methods on different problems. Or you can stick with one, whichever you feel more comfortable with, do that. Do we have any questions on how we set that up, solved it, or got that answer before we do a couple more? We're going to do 22, but we're going to go back and do this one by proportion, and then do 25 and do this the same way we did 21. For 22, actually for all of these, bottom four, It's the same process, but now you have words instead of the ordered pairs. So to set up your proportion, you would have negative 18 over 3 equals 30 over x. And then you could cross multiply. This would be 90 equals negative 18x. Divide both sides by negative 18 to get x equals negative 5. I could double check, make sure that works. Negative 18 over 3 is negative 6. 30 over negative 5 is negative 6. That works. Questions on that one? And then for 25, we're going to go back into the other method. So look at the numbers where you have both. So this first part, k is going to be y over x, or negative 7 over negative 28. We can simplify that by dividing both of them by negative 7. So this would become 1/4. Our equation would then be y equals 1/4 x. And in the second part, now we're looking for y and we're given x. So this would be y equals 1/4 times our x value of 20. 1/4 times 20 is the same thing as 20 divided by 4. So y would equal 5. And if I double check to make sure this works, this does equal 5. And if I put it back in to find k, 5 over 20 does give me 1/4, so that works. Marta?
Are these answers always going to be
That depends on the numbers that are given. If the numbers that are given are whole numbers, then yes. If the numbers that are given are not, it could vary. Any other questions on this process? Yes, Marta.
which method do you prefer?
When grading, it really doesn't matter. I have mapped out grading for both. This has more points than this, but I have it mapped out for both, so it doesn't matter. Yeah, Mr. Number wants to show you guys.
Just real quick on this.
We're here. Okay. I'm going to show the answers to those 4. All of this is in my handwriting, but this method is just the proportion. If you wanted to see it done the other way, just let me know and I can work that out. But for 19, x was 6, 20, y was 21, 23, x was 40, and 24, y was negative 30. Anyone have questions on any of those 4 or want to see it done the other way? We good with those? We're going to move on to the next page where we're doing some applications. Ignore this part right here. You'll see that again when we do inverse applications. So when do we use direct variation in this sense? It's in situations where as one variable goes up, the other one goes up. You could also think about this as the opposite. If one variable goes down, the other one goes down. So they either rise together or they fall together. Another way to know whether we're using direct or inverse is that it will usually tell you, sorry, my voice like cracked. It'll tell you in some sort of wording what exactly you're doing. You should look for something that says like vary directly, varies directly, directly proportional, something like that will tell you you're using direct variation. And then same with inverse, you'll see something similar. What's nice about these two, or these type of problems, is that what we were just doing to find the missing value, we're going to be doing the exact same thing here, there's just words with it. So we're going to do a few of these together and then I'll let you try some. For number one, I'm going to go through and I'm going to read it first. So the sales at a baseball game vary directly with the number of people attending. If the sales for a game are $12,000 when 800 people attend, determine how many people attend if the sales for a game are $15,000. Let's say it together. Okay, so first, it does have the words vary directly, so you know you're using direct variation. With this, what's also nice is whatever comes right before the words vary directly, varies directly, whatever wording it uses. So in this case, sales at a baseball game, that's going to be your Y. And then whatever it says after varying directly will be your X.
So you're saying that every time it says very directly right before that, it's going to be your Y.
Yes.
Okay. That's unusual.
For these problems today, that is not changeable, yes. For inverse, that might be different, but I don't know off the top of my head. And when we do joint and combined, that might be different. But for these today, no, they will not be. If it says the time for now, you can go ahead.
Okay.
Okay. So then the number of people attending would be our X. So again, we can use either method, the proportions, or we find K, put it in the equation, and solve for the missing variable. We'll do one of each. So in this case, if we're using the proportions, we know that it has to be Y over X. Our Y's are the sales, so that would be 12,000 over our X, which is the number of people, which is 800. And then it's going to equal, in the second part, we don't know how many people, so that's going to be our X. But we do know the sales were 15,000. Yes, I'm good. Yes. So then, as before, you would cross multiply. I'm doing this off memory of me doing it earlier today. But you can double check that. And then divide both sides by 12,000. So what would our X be? 1,000. And because these are word problems, we need units, so 1,000, what? Say that again, whoever just said that. People.
I think you added an extra field.
Yeah.
And then it's called.
How many zeros? Not 6.
That's
Because I think it's supposed to be 1,000, and it wouldn't be 1,000 if.
it's 800 times 15.
15,000.
15.
It's 12 million. What is that? It's 12 million. Okay. So that would be if you were using proportions. The next one we'll do the other method. So ounces of medication very directly. There's that word again. So we know what we're doing. With the weight of a patient, if a 120-pound adult requires 3/4 of an ounce of medication, how many ounces are required for a 200-pound adult? So again, ounces of medication are going to be your Y. Really, if you wanted to change this variable to something else, you could do that. You would just have to tell me what that variable is. And you would also need to remember what that variable should have been. So if you change this to M, M is really like your Y, so just know that when you're setting it up. And then the weight of a patient would be your X, or if you change that to like W or P, whatever, you would just need to know that that would have been your X, so that number is going to go in your denominator. So then we can start finding K. Here, our Y value is ounces of medication, and we know that the 120-pound adult requires 3/4 of an ounce. 3/4 would be a fraction, so instead of doing that and having a fraction within a fraction, I'm just going to put a decimal over 120. Someone put that in your calculator, figure out what that is. I think that's the final answer. Yes. 0, 0, 0, 6. A lot of the times, unless you have big numbers like the first example, you'll have K values that are decimals. Realistically, if we were to divide 12,000 by 800, we wouldn't get, we might still get a decimal. So then we can write our equation. Y equals 0.00625 x 15. Okay. So in that case, no, because they were such big numbers, but had it been like 12 over 8, then yes. Okay. And then in this part, we need to know how many ounces, so we're looking for our Y, and we're given the weight of 200, so we're going to put 200 in for X. And figure out what that is. Someone said it. 1.25 and 1.25 what? Ounces. So we're still using the same processes, whatever. But now there's just more words. We're going to do one more, and then I'm going to let you guys try these. We'll do number 5. Before we do number 5. Does anyone have questions on how we set either of these up? Got either of those answers? Yeah, really quickly. Mr. Northrop wants to show you guys something. Yeah, go ahead.
Guys, these come down on the proportion side, they come down to this. I like Snickers bar. Anyway, one Snickers bar costs $2. Okay, these problems come down to the bigger numbers, fractions, but they really come down to one Snickers equals $2. If I spend $4, how many Snickers bars did I get? 1 times 4 equals 2 times x. Same thing. Divide by 2. X equals 2. I bought 2 Snickers bars. That's what these problems come down to. 1 Snickers bar, $2. And then you go the other way. If I spend if I buy 2 Snickers, how much did I spend? You know that in your head, right? 1 for 2, 2 is going to be 4. 1 times x equals 2 times 2. These problems, when you're setting the proportions, are that basic. Just make sure you got the Snickers bars on one side and the money on the other, or whatever we're looking for. That's the key. Make sure you line them up correctly. You don't want to put the Snickers on one side or up high and the money on up high and mix them up. Just make sure they're on the same line. That's what they make for these problems on the proportion side. When you set them up, are that basic. What makes them hard is you get bigger numbers, you got fractions. But as long as you do this process correctly, you will get the right answer. Did I say I like Snickers?
For number 5, the income of a computer analyst varies directly as the number of hours worked. If the analyst earns $256 for working 8 hours, find the constant of variation. So in this case, we're not looking for like X or Y, we're just looking for K. So to find your K, you would still need to know that here we're varying directly. So what comes before that would be your Y. And what comes after that would still be your X. And then look at the numbers we are given. We know that K equals Y over X. So this would be 256 over 8. And whatever that is would be our constant K. Someone put that in your calculator and figure out what that is. For these two. These last two don't have units, but if you wanted to put units to them, you could say $32 per 1 hour would basically be what that constant pay would mean. You have 3 other examples. 2 are like the ones we did above, and 1 is where you find K. I want you to try those 3, and right before class ends, we will go over those 3. Let us know if you have any questions. Again, these are all using the proportion method, so if you want to see the other one, just let me know and I can do that. But for number 3, you should have got 10 shares. 4 was 750 bushels, and 6K was 6. Anyone have any questions on those 3 or want to see any of those done the other way? So before I let you guys start packing up, I wanted to remind you of this. You guys have 4 Khan Academy assignments that are due on Friday. All of them are finding values of K. So can you find the value of K from an equation, from a graph, from tables? And then can you write the direct variation equation? You guys don't have a delta math because there wasn't one. So you just have those Khan Academy assignments. Right? That is all.